Hello everyone and welcome. So today we're going to work on a new project. So this is going to be a coding project using Golang and HTML templates. I'm calling it MD Notes. I know, funny name. So let me explain what this project is going to do. Okay. So basically this is going to be a web-based Markdown editor which will let me create and edit notes in plain simple markdown files. So it will have a directory structure where I can view all the notes, and then a viewer or editor where I can view the notes and edit them as I like. So it's kind of similar to Obsidian if you've used them, but to be used on a web browser. So I've written some basic requirements here. I also created a new Git repository. You can see it's empty with just README. So on the front end side, I'm thinking it should look pretty similar to a standard editor. There will be a left sidebar which will show the folder structure with all the notes in it, and then probably a button for adding a new note. And then the search feature is kind of optional since I have a well-structured note, but I think it would be nice. And then the main section would have a Markdown editor and probably a button to just switch between editing and viewing mode. So I'll be using Golang as a backend for this, and I don't intend to use any sort of database for storing the notes. So everything will be stored as plain text markdown files in the disk, which I can share across my devices. Okay, and on the UI side, it will be simple HTML CSS. I don't intend to use anything like a React or Vue.js or anything like that. So plain HTML CSS, and I'm also planning to use Tailwind CSS because that's going to help me reduce the CSS boilerplate. And I will use Golang HTML templates, which means the UI will be rendered directly from the server. Okay, and once the project is finished, I would also like to build a Docker image. I also have a home lab cluster, a Kubernetes cluster where I have some applications running. So I also plan to prepare the Kubernetes manifest once this is done and then deploy to my home lab. So towards the end of the project, I will also show my home lab cluster and showcase how I do the deployment, how the CI/CD works and such. So stay tuned. Okay, so before I get to this, let me show why I need to build this project on my own. Why don't I use something existing? So I've already done a bit of a research to figure out if there are some existing tools which can be used. Okay, so some of you might have already heard about Obsidian. So Obsidian is a native application. I think it's written in Electron, but I would just call it native for now. Okay, so Obsidian can be installed in your system in Linux, Windows, Mac, whatever. But the only problem is that it's not directly available on the web browser. So here there is a project called Obsidian Remote, which kind of lets us deploy Obsidian in a Docker container, but it's not exactly running natively in a container. So what's happening here is basically it's running an entire desktop in there and streaming that through VNC to the web. You can see that the UI is pretty sluggish, and it's I don't like using this, to be honest. So I already have it deployed in my home lab cluster. It's working, it's doing its job, but it's not very easy to use. As you can see, the right click is not working. I can't copy paste, and you can see some controls for the Windows. That's because the entire desktop is being streamed into the browser. this is not a front end. Basically it's like streaming a video, and that makes it really slow. And another thing I don't like about this is that if I show you the memory usage of this pod running in my cluster, you can see that this is taking 700 megabytes of RAM, and that might sound like very little, but when running in a Kubernetes cluster with very little RAM, this sounds like a lot. So my aim is to build this natively in Golang and HTML templates, and my plan is to reduce this memory footprint to, let's say, 50 megabytes or something like that. It's very easily achievable. Okay, and there's another project which also worth mentioning, that is flat nodes. So flat nodes, this is the demo of flat nodes. You can deploy this in a container. So the idea is the same. You can create nodes in Markdown. They have a nice editor for that. You can preview them. Looks all good. The only problem is that you cannot have a directory structure in this. So every single node is stored at the root. So there is no hierarchy structure for the nodes. That's something I don't like. Okay, so before we start the project, let me also share how I manage nodes currently. So I use NeoVim as my editor of choice. Basically, I have a directory where I keep all the nodes, and then I just use a terminal. I just use NeoVim to edit them. And on top of that, I have a script which I call just nodes, and I can use this script to just browse through my nodes, open it or edit it whenever I want. So let's say I can take this, go through it, expand it, add, edit, or close it whenever I want. So all the nodes are stored locally in a folder in my home directory, and I use syncing to synchronize them across my devices. Okay, so this is already being synchronized across my other device and also my server. So everything is working perfectly at the moment. The only challenge I have is that if I don't have the sync thing set up, or if I don't have this editor set up with all these plugins and the bash script for nodes, it's a bit challenging for me to use these nodes. Which means if I have to use the nodes when I am traveling or when I don't have access to these devices, it's kind of difficult. So that's why it is required for me to have this accessible through a web browser. Okay, so let's start coding. Now before we start, we need a boilerplate, right? We need to have all the directory structure, main.go, some things set up. So for this, I usually prefer to just go back to my own repository and find some past projects and copy the code, the boilerplate code from there. Or I would just say, just refer them. So in this case, I will be taking the boilerplate from this project of mine, which is called TOTPM. Let me just share this project. Maybe it's useful to you as well. So this is what it looks like. It is a simple project to manage two-factor authentication tokens. So if you are already using something like Google Authenticator or 2FA Auth, something like that, this is basically the same thing. You can add new accounts, provide the secret key or the QR code, and this will generate the corresponding TOTP token for you, so which can be used to authenticate against these websites. So I just built it as like a backup solution in case I don't have access to my phone. So as you can see, this is also written so this project is also written using Golang and HTML templates, uh, and it uses Tailwind CSS for the front end as well, which means I can refer this project while and copy a lot of boilerplate code from here. So feel free to check it out. So feel free to check it out as we follow along with the coding. Okay, so here I have cloned the repository into my local folder. So let's start by initializing the go mode file. So I'll do go init, go mode init, and the name of the repository, which should be md notes. Okay, and let's have a look. Okay, perfect. Then we need a command directory which will include our entry point, which should be the main.go. Let me have a look to look at the structure. So inside a command folder, we are not gonna have a CLI and a server, so probably just one. And then similar to this, we need a main function. Okay, so prepare folder cmd md nodes main.go. Okay, then call package main, or will I start with the hello world? What am I doing? Perfect. And now let's try running it. Awesome. Now I like to prepare a make file so that I don't have to run this big commands like go run. So let's see what I have in the make file. Okay, we can have a build test, okay, and also the CSS. Let's just copy the whole thing and then we'll modify it afterwards. Okay, so for the build, I'll output it to bin/md nodes, and the file will be command md nodes main.go. Okay, test will be go test. Perfect. For Tailwind CSS, we'll keep it as it is and we'll revisit later. For the run, okay, go run cmd md nodes main.go. Perfect. We need a go fmt, we don't need. Okay, the watch command is just so that we can edit things in the editor and we can see the changes. So this enter command will automatically rebuild and refresh everything. I'm gonna skip it for now and clean. Okay, bin/md nodes. We don't have a CLI commands. Okay, looking good. Let's try a make run. Perfect. Perfect. Next thing is I'm going to take a quick look at the getignore file and make sure I have everything ignored. Okay, looks like we are missing the bin directory. let's see what I have here. The dnv.out. okay, bin. I just need to add a bin directory here. Okay, next thing. Now let's add the dependencies and set up our server. So I'll be using Go Fiber for this project as the backend framework. So in the main.go we need to add some modules. So let's refer to the TOTP project and let's see what we need. So we are gonna need the Go Fiber v2 module, and then we will need HTML v2 module, that's for the templating, and we also need HTML/template. We don't need all the database or anything else. And then we'll set up the folder structure to set up the handlers and stuff like that. Okay, so let's start by copying fiber template. Don't mind the errors. HTML v2. Okay, perfect. I will just format it. Okay, let's see how setup is done. So the HTML engine is set up like this, using html.new function, which takes the parameters, the folder path and the extension. Okay, let me copy this, and also initialization of the fiber application. All right, so this line set up the HTML engine, and then I'm adding a couple of helper functions here. I don't know if I'll ever use them, but we'll see. So basically, if I need to use some URLs inside the templates, I will need one of this URL helper function. Otherwise, the template engine will render URLs differently by encoding this URL parameters and stuff like that. So let's keep it there, and we'll see if we will need them or not. Okay, and then here we initialize the fiber application by providing the view engine and also a layout file. So the layout file is basically like the structure of the front-end application. So in every page in the application, we'll need to have some structure like the head section, body section, footer section. So all these can be contained in the layout file, and so in the individual pages we just had to provide the content, and the layout will be same across all the pages. So we'll keep it as it is, and we'll see how the main layout looks like. Okay, now Vim is already complaining about a lot of errors because I haven't imported these modules yet. Let's do that. So here I just need to do go mode tidy, so it will download all the dependencies which are defined in the source code automatically. Okay, looks like it is done. Now we should have the go.sum file which will include the hashes of all the dependencies downloaded. Now I also like to do go mode vendor so that all these dependencies are saved in a vendor directory, and then I can push them to Git as well. Perfect. Now I just need to restart my LFP the editor so that it knows about the updated packages. Okay, I don't have. Alright, now those errors are gone. We are not using FMD at the moment, and app. We'll fix that in a second. Now what else do we need? We don't need the database. You can skip that. You can skip the configuration part. Then setting up the handler. Okay, we will set that in a moment. Then we can just do app.listen. Okay, that means we also need to import log. Perfect. So the application should be listening to port 3000 now, but I will need to set up this views folder, otherwise it will complain about that as well. So I'm gonna add the views folder, and then inside that I need a layouts main.html. Perfect. We'll also refer here for that. Okay, so this is going to be the layout. Let's see what we have here. We have the HTML section. The head title will be, let's say, MD notes. Okay, so it has the style sheet in the assets folder. We'll create a folder right away. Assets .css. Okay, then this is included in the font awesome. Let's keep it there. And HTMX, that's also going to be useful later, so we'll keep it there. And then we have a partial template for the heading. Basically the heading navigation bar will be in a partial. Okay, let it be there for now. You know what, I'm just gonna keep it simple for now, and then we'll add them as needed. So let's keep it like this. So it means whenever we use a view to render something, so the entire page, entire content is going to be embedded inside this section, and then this whole page is going to render as a page to the front end. So this will be the layout. Our content will be rendered here. Okay, perfect. And what do we need? We can add the partials, the error message, all those things later. I'm not sure if I'm missing anything. Okay, we have body, div. Okay, I think this is not necessary. Perfect. Okay, so all these classes are coming from Tailwind, so we'll need to set up Tailwind as well in a moment. Let's go back to main.go. Alright, I'm gonna just do a make fmt. So this will format the code, and then let's do a make run and see if it runs. Okay, I don't see any errors, but so it looks like it's running. Let's try localhost 3000. Perfect. Cannot get slash because we don't have anything running on the path slash. Looking good so far. Now we need to add a route and render something in the page. Okay. For that we need to set up a handler. So I'm going to create a folder called pkg, and let's say handler, handlers, and I'm gonna refer this here. So we'll have a handler inside that API and render. Okay, looks perfect. Handler, API, and then render. So we're gonna set up two separate directories, one for the pure APIs, which we will need for server client communication. So this API folder will include just the REST API functions, which does not include any views, and this render folder is going to include all the functions which are going to take the data and render the front end using the HTML views. Okay, it's just a logical separation. Alright, and let's set up the render function. So we don't need all these parameters, database, store, let's set up a structure and just let's start with the hello world, shall we? So render.co package render. Okay. Renders. I'm really bad at typing. What do we need? So here we have render error, require auth. We don't need all this comment. So let's just do func slash render index. Okay, so this is going to be the index page. What do we need? We need to import the fiber and then render it like this. Perfect. So this is going to, let's import fiber first. Okay, so here it should take c fiber.ctx as a parameter, then return c dot render. Okay, so what will be the template? Template is going to be index. And I don't think we don't have any variables to pass, so let's keep it empty. What did we miss? Okay, should return error. Let me see if I got this index correct. Okay, I also need to pass a third parameter, which is going to be the layout. Never mind, I think I already set layout. Okay, so I need this index.html file here. So here I'm just gonna say h1 hello world. Okay, now so we had to set up, okay, we had to initialize this render and then basically set up the routes like this. Perfect. Then I'll have function new render which returns a render object. Okay, let's keep it like this. Probably we'll need some parameters later, but for now let's keep it like this. Now in the command I can do r equals to render dot new, what is it, new render. Okay, did I miss something? Package handler render. Okay, this file is within module dot, which is not included in the workspace. I don't know what it means. Let's continue. Let's try to do a make run. R is declared not used, makes sense. App dot get slash should do r dot index. Basically, whenever we hit the URL slash, it should use start.index method to render the index.html file. Let's try to run that. Okay, looks like it's working. Refresh. Hello world. Ta-da! Alrighty. Now the next thing is we need to set up Tailwind CSS. So if you open the source code here, you can see that it is loading app.css, but it's not there yet. And it is also including font awesome, which will be useful later. Same story for HTMX. The thing is, this container class and MX auto class does not exist yet because Tailwind CSS is not rendering the CSS at the moment. Let's see how we can do that. So for that, you can see here we have a script called Tailwind CSS. So we need to have Tailwind CSS CLI installed to make it work. So you can do that by doing npm install -g Tailwind CSS, or you can refer to official documentation. I already have Tailwind CSS installed. So if you do Tailwind CSS init, it should set up the Tailwind CSS config file automatically for us, which will have all this configuration. I think we can leave it default. Okay, so we just need to provide the folder where we have the HTML files. So we can copy it from here. So what it means is whenever we run Tailwind CSS build, is it build? Yeah, whenever we run this command, it's going to scan all the HTML files in this views directory, and whatever CSS classes we are using in these HTML files, Tailwind CSS will generate the corresponding CSS code and export them into the CSS file which we specify. So in this example, we are taking the input from app.css and then outputting it to asset/dist/app.css. So Tailwind CSS is going to copy all the custom CSS we have in this file, combine it with the classes it is generated, and then output everything into this folder. Okay, so let's see what we have here in the app.css file. So here as you can see, it is empty because I haven't written any custom CSS in that project, but here it is including the base components and utilities using that Tailwind directive. So after Tailwind builds the classes, these components will be included in the output, and you can see the output here. So this whole thing is generated by Tailwind. Okay, so I'm gonna copy these things. Oops, I mean copy, and add it here. Perfect. And I also need this command to build the CSS file. Okay. I already have it here. Perfect. Let's try that. Make CSS. Okay, there is a outdated warning. We don't care about warnings, right? Let's leave it there. Okay, building is done. Let's see the output. So in the dist, I have the app.css, which has everything. Perfect. So for example, in the HTML file, I have used container and MX auto. So this should have the corresponding definitions for this. So here you can see MX auto and container. So all these classes are added by Tailwind CSS because we are using them. Okay, now we also need to make sure that this dist folder is being served to the front end by Fiber. That is something we missed. So let's take a look how it was configured. the command server.co. What do we have in it? Should be called public. Assets. Okay, so app.static assets. All right, let's add that into our main.go. So what it means is that anything with the prefix of /assets will be served from assets/list folder. Okay, perfect. Let's do a make CSS once more just to make sure, and then do a make run and try again, and voila, you can see the difference already that the CSS class is loading. So this is now in the container. That's why you can see these margins on both the sides. And if I inspect the source and open the CSS file, you can see it is loading, looking perfect. You can also just inspect and make sure that the classes are correctly loaded. This is the container, MX Auto, looking good. So it looks like our initial structure is done. Then now I'm gonna commit this to Git and continue the remaining coding in part 2 of the video. See you soon.